We will see in this tutorial the rocker of the surfboard. The rocker is one of the modules that defines the board. We have seen in previous tutorials that there are several modules in a board. The outline, the series of sections, and now we are going to deal with the rocker. To be more exact, we are not talking about the rocker, but about the couple of rockers, because there are two rockers in one board. We apply the wireframe display, and we go to the Shape tab. And in the Rocker tab, where we see at the bottom, the rocker image, we are going to open in its modification interface, the rocker editor. This rocker editor shows us, in the upper part of the graph here, the different shapes of the bottom, in section according to the points. We start from the tail here, which is point 0. And we go all the way to the nose, which is point 1. As a reminder, when we talk about the dimensions of our board here, we have freed ourselves from the actual dimensions, and we are talking about a board that is 1 in length. So if I'm at position 0.5, I'm in the middle of the board. With these marks there, it is easy to locate yourself on the board. So at position 0.1, 1/10 from the board, we see the bottom here, with little blue dots. It's an almost flat bottom with a little V. And if I go to the front of the board, at that point, so at the 0.9 point, we see a little concave, with an angle of -2.4 degrees on the bottom. Here is the rocker interface. In the upper part, we see sections that show us the bottom in different places of the board, and in the lower part, here, we see two lines. Here, a red line that shows the central rocker, the rocker of the core of the board, and a green line here, which is the rocker of the rails. The green rail rocker line is a line that represents the series of points that would be at a distance of 0.25 from the center of the board. And we can modify the bottom angle by lowering or raising this line. If I raise a point of the green line above the red line in the center of the board, we will see here, click on Apply to the project. Our board deform, with a point in the center, which is higher than the point on the outside here. This green line is a series of handles, with which you raise and lower the rail rocker. Here I put the rail rocker points back, below the center rocker points. Applying this rocker transform to the project, we see the bottom of the board, which becomes concave, right here. So with these two lines, the central rocker line and the rocker line of rails, we are piloting the angle that the bottom makes with respect to a theoretical flat surface. There is an interaction between the rocker and the section. Here we see the green line which represents this line here. If I enter in my rocker editor the handle of the green line here, and I raise the point, I modify the angle of this line there. Then we will apply. We will see here in the drawing at the bottom, we will monitor what's going to happen. We see that here this green line is up. I put the board in the same direction to see better. Bottom right, it's like I grabbed my rail here and pulled my rail up. So we see that with these two lines, the green rail rocker line and the red center rocker line, we are driving the side angle of the bottom. When I select a point in the rocker editor, the software selects the corresponding section. On the section, at 0.8, the bottom is a V. I'm going to go concave. I'm just going down my rail rocker line. I apply this new line and we see that my rail rocker here generates a V zone. I check here we are in V, and if I come in front of there, at level 0.7 and 0.8, apply the rocker to the project. We see that in this area there, the bottom is concave. In the lower diagram representing the section, that's the center of the board, that's the rail. We see we're concave here, and if I go to the rear, we see we're in AV. So the rocker really helps drive the way whose section is oriented on the board. The definition of rocker, and the way to measure it, varies according to the literature, the shaper, the country, and fashion. In fact, in the 70s, we had a very linear rocker on the back. A bit like the red line here. On the boards of the 70s, the rocker is flat on the back. And we were only talking about the front rocker. And we had boards that had this type of fairly flat rocker. And so the measurement was simple, we put the board on a flat surface on the back. And we would measure the distance from the nose to this surface. The rear being with a zero rocker. But now the boards have rocker on the tail. Curves on the tail that are pronounced, that way of measuring rocker is no longer valid. Because in fact, we can no longer press the back of the board on a surface to make the measurement. The board would tip over without finding a flat surface of reference. So, to measure the rocker, with a precise and repeatable method, we center the board on its white point, on the position, therefore the widest. If I look in the small diagram at the bottom left, we see the wide point. The position is a little before 0.5. We see here a small point which shows the position of the wide point. And centered on this wide point position, we draw a horizontal line, in black dotted lines, exceeding 0.25 on each side of the wide point. The bottom of the board, placed on these points, thus gives us the horizontal reference, on which we align the ruler. If we change the scale of the board, our scaled rocker will still be valid. Attention, for methods that use fixed distances, such as, for example, 1 foot or 2 feet or at 50 centimeters or at 1 meter around the wide point, these rocker measurements vary the direction of the tangent surface. If we modify the board, we will therefore prefer the dimensions standardized on the length of the board. So, 0.25 times the length of the board on each side of the wide point, for our horizontal alignment. This is a purely technical detail, on the way rocker is measured. In our editor, when we modify a point on a rocker line, when the point will move, we will automatically switch to drawing mode. And we will see orange rectangular handles, which allow the rocker line to be deformed. The old rocker line remains visible, for reference. And we see the new line taking shape. Until I press apply, here this row will not commit. The line can be more or less tense. We can choose the degree of flexibility of our line. We will stay on level 3 to get a nice rocker line. For the rocker, we will prefer low degrees to obtain taut lines. So there you have it, the line tracing tool, which allows us to keep a harmonious line. So there, my line has been applied to the rail. But at this stage, I have not modified my 3D model. It must be applied here to the project. And there, we applied our rocker. We have on the right of the editor, tools, to globally accentuate the concave. More or less, or accentuate the V. Apply to the project. Here, we will look at our board. We're going to add concave. Bringing the rail rocker line down, I'm going to overdo it, and apply that to the project. We see a strong concave. We will now apply more V. We see the red line of the center rocker going down from the green line, which represents the rail's rocker. In the diagram above, we see that the background also transforms. So we can see in gray the old shape of the bottom. I increase the concave, or I increase the V. The background is thus transformed. So we can sculpt the bottom very precisely by controlling the rocker. Here, we can double the vertical scale. This allows us to work on the lines more easily. This allows us to make very precise rocker variations. When I select a point from the central rocker, the distance from the reference surface is displayed in millimeters and in inches. If we display only the angle rocker line, we display the bottom angle. So in concave, here, on this zone, we will have negative angles. And when we go up in V, we obtain positive angle values. A positive bottom angle value is V, and negative bottom angle value is concave. We will be able to record the couple of rockers. And therefore in our library, in the modules, which we insert into the boards, we will find our test rocker couple. Right here. When we select a rocker couple, in the library, we see the center rocker curve, and the rail rocker curve, with a scale multiplied by 2. Multiplying by 2 allows us to better see the character of the rocker. This is how we insert a rocker easily into the board. We take the rocker, we drag and drop it on our board. So here we have seen the rocker couple, which is the third main module of creating surfboards. So we have the outline module, which really defines the board. We have the series of sections module, which determines how the volume is distributed along the board. And the rocker module, which describes how the bottom is sculpted. So with these three modules, outline, series of sections, and couple rockers, we determine our surfboard in the Shapewaves Dynamics software.